All right, so we're going to work on these Hardy-Weinberg equilibrium problems, which are found. You can find these worksheets on Blackboard. So I posted two of the worksheets on Blackboard as well as answer keys to both of those. Now we're going to start off with the one that starts off with a p equal to 0.40. So one of the things we have to remember is p plus q equals 1, and p squared plus 2pq plus q squared equals 1. And so here we have a couple of problems to try to figure out what all these letters are. So the first one, we're given p. Now p is equal to 0.40. And it says, what are the gene frequencies of a population? So we have to figure out what the rest of these are. So, using this equation, if we do simple algebra, to determine what q is, we're going to take p and we're going to subtract it from 1. So q equals 0.60. All right? To find out what q squared is, we're just going to take 0.60 and we're going to square it. So 6 times 6 is 36. Move the decimal over 2 spaces, 0.36. To find out what p squared is, we're going to take 0.40 and we're simply going to square it. So 4 times 4 is 16, so 0.16. To find out what 2pq is, we're going to take 2, we're going to multiply by p, which is 0.40, times what q is, 0.60. And so 0.6 times 0.4 is 0.24, times 2 is 0.48. Now what we should see here is that these two numbers equal 1, p plus q equals 1, and these three numbers should also equal 1 because p squared plus 2pq plus q squared equals 1. All right, well, let's look at the second problem here. So let me just write these down first. All right, so on the second problem, what we see here is it says, if 26 people out of 131 have albinism, which is a recessive trait, in that population, fill in the following spaces. All right, so the question is, where do we begin here? And we're going to begin with q squared. And the reason that we start there is we know that q squared is the frequency of the recessive alleles. All right, we can't look at the people who don't have albinism because they could either be in this group or this group. So they could be homozygous dominant or they could be heterozygous. If we know the frequency of the recessive people, we can figure out what everything else is. So we're going to take 26, we're going to divide it by 131. And so if we take 26 and we divide it by 131, that equals like 0.198 or 7 or whatever, something like that. So it rounds up to 0.2. To find out what q is, we're going to take the square root of 0.20. And the square root of 0.20 is 0.45. And from that, we can find out what p is. We just subtract that from 1. So 0.55. To find out what p squared is, we take 0.55 and we square it. And so that's going to equal 0.3. And to find out what 2pq is, we're going to take 2, we're going to multiply it by 0.55 times 0.45, which is what q is, and that's going to get us 0.50. Okay, so let's look at the last problem on here, which is problem 3. And problem 3 states, if 32% of a population has a recessive phenotype for a trait, what does the p equal? So 32% of the population has a recessive trait. So that is the q squared once again. And so that's where we're starting. So 0.32 is what the q squared is. So we can't directly go to p. We have to find out what q is next. So to find out what q is, we're going to take the square root of 0.32, and that's going to equal 0.57. And we subtract that from 1 to get us what the P is equal, and that's 0.43. So, you should expect on the next test that there will be Hardy-Weinberg problems in a multiple choice form. So I will give you, the starting point here, and then I will ask you to find out what P is or Q is, or one of these other numbers, and you're going to have to figure out what it is. All right.